The last thing we need to cover is the volume about the y-axis. Alright, let's do a quick recap. Area. Okay, so we have area about x-axis. We need y the subject. Okay? So, with whatever the axis of bound or rotation, you need the opposite letter, the subject. Okay? For area, so if we're about the y-axis, we need x, the subject. Okay? Now, for volume, so we've just covered volume rotating about x-axis. What do I need the subject?
Y squared.
Y squared, the opposite letter squared subject. And the integral is the pi out the front from the bound. Okay? You need to have that pi because of the rotation. Like this there. Right, so the volume about the y-axis. What do we need the subject?
X.
X squared the subject. Okay, and we need pi integral from b to a of x squared dy. Alright, in other words, integrating with respect to y. Okay, so whatever the axis of the bound or the rotation by, the opposite letter needs to be the subject. Okay? You need to remember that. Right. So again, it's the same concept, finding the volume at the y-axis, same as taking the sum of multiple circles, add them together to produce the volume. Okay, example A. We need to find the volume. So we get the line y equals x. Between the ordinate, y is 1 and y is 4. Rotated about the y-axis. Okay, we need to find the volume form. So the approach is pretty much the same. Okay. So the first thing I need to do is consider a sketch. Now I've got y equals 1, y equals 4, so they're both going to be in the first quadrant. So really I only need the line up to that point. Okay, I don't need to do the whole graph. Right, I'll just make it enough for me to be able to put the information I need. The line y equals 1 and y equals 4. Okay, so remember a line y equals c cuts the y-axis at c. Right, so y equals 1 cuts the y-axis at 1, y is 4 cuts the y-axis at 4. Okay, so you are finding that shaded area there, and then you are going to rotate that around like a one of those sports cones with the top cut off.
What is that?
Okay.
What is that?
Like one of those sports cones with the cone but with the top cut off.
Yeah.
Yep.
I know what you said.
Yeah. Okay. Alright, so volume is going to be pi integral from b to a. Now it is about the y-axis of the rotation, so I'll need the opposite letter, the subject, the x squared. I'm going to integrate that with respect to dy. So the dx dy is the same as the axis of rotation or the axis of bound. Okay, so x is y, x equal to y. Alright, nice and simple there. So x squared equals y squared. Effectively, we're finding the area of a parabola between 4 and 1, and we're rotating it around the axis. Okay? So, pi, the bound from 4 to 1 of y squared dy.
X squared dy?
So,
Y squared?
X squared is y squared, so
What?
x squared in this is still
x is y, so x
Y.
squared is y squared.
but we're
But isn't it
Do we-
rotated around the y-axis?
yeah,
It's X squared?
but because x squared equals y, we're still deriving it with respect to
I
y.
don't understand.
This should
Shouldn't it be?
it would be the same thing if we did dx. Oh,
What do you think it should be?
Shouldn't it be x squared dy?
wait, go back to
Yeah.
the other ones.
Yeah.
When it was around the
The y
x-axis. When it was around the
That's the
x-axis,
formula.
Yeah.
the same kid. You swap it
Yeah,
over to the
this
other.
but this one, for these ones,
Is it just coincidences?
Yeah, just
Yeah.
coincidental.
Alright.
Chill.
Now, when I integrate, I'm observing this is a y cubed over 3. What I'm going to do, take the 3 denominator out the front. Alright, so pi over 3 of y cubed. Okay, you can do this as long as you're understanding what's happening. Okay, looks like you don't.
Oh, I got it now.
Yeah? Okay, y cubed over 3.
Yeah.
So instead of 3 here, I'm putting it out here. Alright, I'm just making an observation there. Alright, if you're not comfortable with that, you need to take your steps. Alright, so I've done quite a bit of integration now, so I'm just showing you different techniques. That equals pi on 3 outside of 4 cubed, take away 1 cubed. And the reason why I've taken the 3 denominator at the front because it's going to be a factor of both those terms with a bracket. Alright, 4 cubed.
64.
Same as 2 to the other 6. Alright, pi on 3, 64 take away 1, 63. So we're going to be 63 over 3, which simplifies to what?
21.
8, 21. Pi.
I keep forgetting the cube.
Oh, it's right.
Everything squared.
So, well, yeah.
Okay, area, squared unit, volume, cubic unit. Alright, now if you get through the whole question, if you accidentally put unit squared for a volume question, now I think it'll be a harsh mark taken off you at that stage, but certainly if there's no unit, that's a justifiable mark taken off you. Okay, if there are no units at all. Okay. They do allocate questions in your HSC. One question, if you don't have the correct rounding, you will not get the full mark for that question, that specific question. Okay, and another question, if you don't have the units or a plus constant with a plus Charlie or an indefinite integral, okay, you can also lose that mark. Alright, so there's 2 marks out of 100 in HSC for mathematics. Right there. Okay, so if you can round correctly and you can include the correct units, right, you got 2 out of 100 so far. Alright. B. Right, so the curve y equals 3x squared, rotated about the y-axis. Between y equals 0 and y is 6. Find the volume formed. Right. What's the graph? Parabola.
It's quite a skinny parabola.
Multiplied by constant means it's going to be a what parabola?
Skinny.
Steeper.
Steeper.
Or narrow. Okay, now that detail is not important, okay, because the detail of that is the parabola is what's important. Okay, I'm not worried about the 3 at the front. Okay, just a general representation of the curve between y equals 0 and y equals 6 is rotated about the y-axis. Okay, so
It's going to be like a sick thing.
so really it's this bound as well, but I'm going to ignore that because it's getting rotated anyway.
Oh my god, it doesn't make
Okay.
sense. Silly me.
Okay, can I make that point again, everybody? You've got this part of the parabola, and yes, you've got the y equals 6, but because this is getting rotated about the x-axis, about the y-axis, sorry, it's going to take into account this section here. Alright? So, really, what we're doing is we're neglecting that.
Huh?
Why do you have to discuss every single shape that we make?
Some shapes don't, okay?
Yes, so it's a very, very steep breakfast bowl.
So I just name the shape and like play
You
it.
might as well if you want to.
Champagne glass.
Yeah.
Champagne.
I don't know how different types of like
That's not that
alcoholic glasses are.
That's
The really skinny ones.
So
skinny ones.
Yeah.
There's one.
No, I'm not finished yet.
Shredded.
Okay, x squared dy. We need x squared as the subject of this equation. Right, so x squared is y on 3. But I already have x squared. Okay? I already have it. Y over 3 dy. Okay, now this is the same because I'm dividing by constant, so pi on 3, integral from 6 to 0 of y dy. Okay, so the more constants I can remove, the less working I have to do inside the bracket because I've already factorised it out. Okay? Alright, so this is going to be y squared on 2. Right, so I'm also going to bring that 2 out, so pi over 6 of y squared from 6 to 0. Y on
Oh, that felt really good.
6, so 36 to take away 0, so it's going to be 6 pi units cubed. Now remember, this is a very steep parabola, so this actually gets narrower than a normal parabola. That's why the volume is so small, relatively speaking. Okay, much smaller than this. Right, because it is very narrow as you get to the y-axis. Right, so that's why the volume is so small. And that
So
is
if I had a parabola 6 centimeters high,
Yep.
it's perfect.
Of that equation, yep.
Would equal 6 pi.
Approximately 20 centimeters cubed, yes.
What?
And I'm actually very glad you got up because there's a very similar question next question.
Good boy.
Okay, so you notice in real life how there are like glass and bowls and vase of very unique shapes. Where do you think the pattern for the unique shape come from?
This. Yeah.
Okay. A mould for producing glasses is made by rotating the area bounded by y is x cubed, the y-axis, and the lines y equals 1 and y equals 8. Y equals 1, y is 8. Rotating the area bounded by that, the y-axis. Okay, this is rotated. Okay, we need to find the volume of the glass. What would the volume of the glass be if the unit of measurement is in centimetres?
That's an S.
So,
Oh, that'd be groovy.
cubic.
I was just about to ask about one of those.
That'd be groovy.
Oh, what shape would that be?
Like
An hourglass.
Yeah, that's cool.
But it gets to a point where it doesn't exist anymore.
Shut
That's
up.
like,
God don't remember one of them then.
Y equals 1 and y equals 8. So, there's your glass prototype. Okay, so the very nice cubic glass that you see in the shots.
I really want to play with the 3D.
You have to make a mould to be able to produce the glass, to be able to get the correct shape and volume. Even just making glassware or bowls or
Something.
thing along those nature requires this sort of stuff. Okay? So, volume, we're about the y-axis, pi integral from 8 to 1 of x squared dy. So we're rotating about the y-axis, we need the opposite letter, the subject. Okay? So, x cubed is equal to y. I need x squared, the subject.
Differentiate.
No, it doesn't give me a new equation, it gives me the other function altogether.
divided by x.
Square root it.
Square root.
No.
So then you go.
You're on the right track.
Wouldn't it be divided by? If you divided by a single x on both sides, so y.
Yeah, but I'm going to have a variable of x on the same
Oh, yes,
side, but I'm
that's
substituting here. I don't want that.
What did you say something
Where was it thinking?
So we don't want an X on the right hand side.
No, no.
about? 3.
Word.
3 times what equals 2.
Oh, what?
Couldn't bother.
This is 2.5.
What?
0.25.
What'd you
I'm trying to whether 5 and 4 in one.
3 times what equals 1.
I thought it
That's it. So 3
Oh.
times what equals 2.
It's like, that is. Oh my god, I never gonna do that.
Very sad.
0.25? 0.25?
We do that all the time.
I hope no one ever thought this.
Alright, so if I take this to the power of 3, 2/3.
Oh, so this is how to do it. I've always been trying to figure out how to do the power ones.
Yeah, get something out today.
I didn't know how to do them.
Alright, and use your power to a power rule, so x squared is equal to y to the power 2 over 3. Okay, using your prelim topic 1 index laws, stuff that you've done in your 9 and 10 as well.
Oh,
Stage
yeah.
somewhere.
You should have dropped to general.
Pi 8 to 1,
Tax?
y to the power 2 over 3, dy. So I don't want to have another letter, particularly the dependent variable, associated with my integration. Otherwise, you cannot integrate. And when we fall into that dilemma in extension 2, we look at ways of getting around it.
That looks like fun then, Carl.
I'm dropping.
Robin, you're
Ah. Equals pi. Right, so that plus 1, 2/3 plus 1.
7.
Eh?
What?
8.
What? What? 2/3 plus 1.
5/3.
5/3. Imagine other students probably thinking, 2 students who are watching these videos and thinking, well, these guys can't even do math.
Goddamn rules.
Alright, pi, so it's going to be 3 pi on 5, so dividing by a fraction, we multiply by the reciprocal of y to the power of 5 over 3 from 8 to 1.
Wait, what?
What did you say period 3?
Per 3.
What is it?
Yeah.
Oh, I forgot what it was.
What is 8 to the power
Punch you in the neck.
of 5 over 3?
You can say no to
Oh, you will say.
that. What's 8 to the power of 8 to the 5 cube
9.
root. 8 to the 5 cube root. Cube root of 8 to the 5. Take away 1. I don't know what that is. I have to put that in the calculator.
No, you don't.
8 times
What is the cube root of 8?
2.
2 to the power of 5.
Dad,
64.
1 before 64.
Yep. Shit.
62. 36.
63.
36.
Did you hear that?
Yeah. No.
16.
You probably just went like forward.
So 31.
Don't say it.
32.
Did you say 32 take away 1?
No, he said 64 and it said, it was to the power of 5 and to the power of 6 is 64, so he said 62.
At least not as bad as Snowy. I'm pretty sure last year I asked him something like 2 plus 1. And he said 2. I think we have a running joke about us.
There was one problem he got.
Yeah, 2 times 1. And he called out 3.
Yeah.
Yeah.
He also were in
We've done
geography
something.
one day, and
I hope he's not going to be balancing books at that.
no, he was in geography one day, and he says, "Oh,
Oh yeah.
were they in
We were
black
watching
and
a
white
black
back
and
then?"
white video. He's like, is that how they saw back then?
In black and white.
Do you remember Jordan's series?
Alright, I'm not finished.
The boats, man.
The last thing needs ready.
You just
Centimeters.
Oh, yeah, centimeters.
Alright, you were told that they were in measurements of centimetre. You are needing to answer in centimetres cubed. Okay?
Too easy.
Now, that covers everything in the theory. So that's now exercise 3.9, I believe. Volumes. I believe both the X and Y are in one exercise.
what is this?
Well, it's 3.8.
3.8.
Yeah.
That's what we do.
That's
We've done that
It's
software.
literally.
It's just